So this is my RMI demo for just executing a command in one client and seeing it executed in the other two non-inputting. So I've just executed move 100 0, and as you can see, we are getting the value from the entry. We're in my RMI command object, and we're going to call execute command for each client. So entry is a map that has a callback for each client on my server, and so now that we've run it, you see that we've called execute command and we're in the client callback now. The client callback is registered when each client connects to the server, and is how the server invokes commands or state changes in the client. As you can see, we're now in client 3 launcher, even though the command was inputted in client 2. So now you can see that we're fast forwarding through. We're now in the client and we're executing the command by calling process on the command processor. And again, we're in client 3. So if we fast forward through these, you're now going to see the server launcher calling execute command on the next client. So now we're in client 2 launcher, we execute it, client 1 launcher, we execute it. Now if we look at the GUIs, you see that each one has moved forward by 100 spots. Now I'm going to demo two non-commuting commands executed across two clients. So first I'm setting atomic to false in my client launcher 1. And now I'm going to try and execute to take 1. And I've set breakpoints so that those commands have not yet been broadcast to the server. In my client 2, I'm going to move, and then this client is an atomic. So what we should see is that one client takes, and then one client is not able to take, because one is an atomic and the other is a non-atomic. So now as I step through the server broadcasting the commands out, once we're done processing all these commands, we should see that client 1 is in non-atomic mode, has taken one cupcake, and has also moved forward, whereas client 2 has moved forward but not taken another cupcake. And that's exactly what we see. Next, I'm going to demonstrate the testing phase for this section. The time for local only was 0.36 seconds, but is not shown in this part. So first we're going to run the tests for atomic, and we can see that took 0.56 seconds, or 0.51 seconds rather. Next we're running it for non-atomic, and we see that took 5 seconds. The reason for the differences here is that for atomic we're really only tracking the time it takes to call the server and not actually complete any movement on the GUI, whereas for atomic, or rather non-atomic, we're kind of interleaving the execution of the commands that change the GUI with the sending the messages to the server. So we see that the non-atomic takes longer because we're simultaneously trying to update a graphical interface while also sending the commands out.